Chantel, now you can start recording. So hello, everyone. Thanks for joining the Computer Science Colloquium talk from Pardis on empowering people to have a secure and private interaction with the digital technologies. So this topic getting more important with a growing number of IoT devices these days. So Pardis is a postdoctoral researcher at the University of Washington. She received her PhD in computer science at Carnegie Mellon University, and her research is broadly at the intersection of security, privacy, usability, and human-centered interactions. So our speaker has a great depth of experience in this field, and her research has informed the NIST and Consumer Report and the World Economic Forum in their effort toward designing usable and informative security and privacy labels for smart devices. Please welcome Pardis, and yeah.
Thank you so much, Sante, for this great introduction. And let me start sharing my screen. Okay. Awesome. So you can see my slides?
Yeah.
Great. Okay. Yes. Yeah. Thank you so much for this great introduction. And thank you, everyone, for being here today. My name is Pardis Emami-Naeini. I'm a postdoctoral researcher at the University of Washington. Today, I will be presenting my research on designing security and privacy solutions that empower people to protect themselves when interacting with digital technologies. My research journey started when I was an undergrad student in computer architecture at Sharif University of Technology in Iran. Back then, I got trained and became interested in hardware and system security. And to me, security was basically equivalent to having secure systems and hardware. For my PhD, I joined the societal computing program in the School of Computer Science at Carnegie Mellon University. It was only then that I realized that aside from systems and more generally technologies, there are two other components, namely policies and people, that I was previously missing. Having secure systems and technologies does not create a secure society unless we consider these three components together when designing security and privacy solutions. I conduct human-centered security and privacy research with this core belief that the design of technologies and policies should be directly informed by people's security and privacy needs and concerns. More concretely, in my past research, I primarily focused on surfacing the security and privacy needs and concerns of non-expert users and consumers. Then in terms of technologies, I have studied remote communication tools and conducted extensive research on consumer Internet of Things or IoT technologies. And the policies that my research has explored so far covered employer or company level policies all the way to the national and international policies and regulations. Okay, so now I'm going to talk about the main contributions of my research with respect to each component of this concept of human-centered security and privacy. In addition, I will discuss the important challenges to make each contribution. So far, we've talked about the importance of technologies and policies to be informed by people's security and privacy needs and concerns. For this to happen, the first step that my research takes is to obtain a foundational knowledge of people's concerns and identify how they can be empowered to protect themselves against the security and privacy risks. But this is especially challenging as we cannot simply ask people about their concerns and preferences, since the majority of people lack adequate security and privacy knowledge to be able to identify what their concerns and needs actually are. The user studies that I designed and conducted are carefully constructed to surface people's security and privacy needs and concerns in relation to their knowledge and familiarity with the topic. In terms of security and privacy tools, I use the knowledge that I obtained to address one of people's most common needs, which is having effective transparency on security and privacy. I designed a usable and informative security and privacy transparency tool for users and consumers of smart devices. An important challenge here was to design quantitative and qualitative methods to measure the efficacy of the tool in informing consumer security and privacy purchase decision-making. Last but not least, my research has resulted in actionable recommendations for various stakeholders to design technologies and shape policies that protect people's security and respect their privacy. In addition to the research component of my work, I care deeply about the societal impact of my research. And for that, I did not stop at proposing recommendations. Indeed, I'm actively engaging with diverse stakeholders from the US government agencies, such as the National Institute of Standards and Technology, or NIST, to nonprofit organizations, including Consumer Reports, to international bodies, such as the World Economic Forum, to inform their efforts in improving the security and privacy state of consumers of technologies. This has been my work from home setting for the past 2 years. And I'm going to use this picture to describe the outline of the rest of my talk. I will present my research related to 2 technologies in this picture that best showcase my human-centered approach to security and privacy. The first technology that I'm going to talk about is the remote communication technologies, which for me was mostly Zoom. During the COVID-19 pandemic, many of us, if not all, have used at least one remote communication tool to connect to our friends or colleagues. And the second research direction that I will focus on involves multiple projects on the security and privacy of Internet of Things or IoT technologies. Here, the smart device that I have on my desk is an Amazon Echo. Starting with the remote communication technologies, I'm now going to talk about a research study that I conducted to understand people's security and privacy attitudes and concerns toward remote communications during the COVID-19 pandemic. Since late December 2019 and early January 2020, the world was hit by the COVID-19 pandemic caused by the novel coronavirus. To prevent the spread of the virus, people around the world started using conferencing tools to work, socialize, and learn from home. These tools, however, expose their users to a wide range of security and privacy risks. To understand people's security and privacy concerns and preferences toward remote communications during the pandemic, I designed a large-scale online survey and launched it in the May of 2020, a few months into the pandemic. I sought to conduct this research during the transition phase of the pandemic, when people were still adjusting to their remote settings and experiencing these challenges, while remembering their normal lives before the pandemic. And the reason that I picked this specific phase of the pandemic was that research has shown that familiarity with the technology significantly impacts attitudes and perceived concerns toward that technology. So I wanted participants to have enough experience with remote communications to be able to talk about it without being used to it. For this survey, I analyzed data from 220 participants from Prolific, which is a commonly used crowdsourcing platform. Most of the participants were from UK, Poland, and US. 57% of participants identified themselves as male, and 43% identified as female. Almost all of the participants were below the age of 50, with the majority being 18 to 29 years old. And most participants did not have an education in or work in the fields of computer science, engineering, or information technology. A few of these demographic factors, such as gender, had a significant impact on participants' security and privacy attitudes toward remote communications. And if you're interested in knowing more about the impact of demographic factors on participants' responses, I have some backup slides on this. In this study, I explored participants' security and privacy needs and concerns toward 3 main contexts of remote communications: working from home, socializing from home, and learning from home. Each participant was asked on all three contexts, where the questions of each context were presented in a separate block of the survey. I then randomized the order of these blocks to mitigate the potential order bias, which is a very common type of bias in user research. In our remote communications, we had to, and still have to, constantly make different decisions. A few of these decisions could be what conferencing tools to use for our meetings, whether or not to activate the audio or video in our meetings, and which room of the home to use for our remote meetings, bedroom or perhaps the bathroom. And these decisions could result in some consequential security and privacy risks. For example, there are several reports on people's webcams and microphones getting hacked during the pandemic. To raise users' risk awareness and avoid such incidents, my goal here was to better understand how much participants valued security and privacy in their decision-making, and how similar or different these decisions were among the different contexts of remote communications. It is also important to mention here that I designed the survey questions to capture participants' unbiased security and privacy attitudes without prompting them to think about these concepts when taking the survey. Before going into the details of how I analyzed participants' data, I want to share the most important takeaways from this research. And for that, I'm going to use my human-centered agenda, which I talked about at the beginning of my presentation. As a reminder, my research approach is human-centered security and privacy, which means that I center people and learn from them to inform the design of technologies and policies. The first step is to identify people's security and privacy needs and concerns. Now let's take a look at a quote from one of our participants. If the manager asks me to turn on the video, I have to do it, but I personally prefer to maintain it switched off at all times. So this participant, although having privacy concerns, expressed lack of control over using their webcam when working from home. In this study, the most frequently mentioned need among our participants was the desire to have meaningful control and agency over the remote communications. In all three contexts of remote communications, participants, despite having privacy concerns, reported that they had no effective power on deciding what conferencing tools to use or whether to activate the microphone or webcam in their remote meetings. Such meeting policies were usually made by their employers or their teachers without them having any control over it. Even in the very casual context of socializing from home, participants felt this pressure to always keep their webcam on, not to disrespect their friends or family members. The most common type of privacy concern among our participants was the lack of remote privacy, which is a lack of privacy from other meeting attendees. To address this concern, tool developers should provide an equitable access to the virtual background option for remote meetings. Maintaining remote privacy was especially challenging for participants who were living in shared settings. And because of that, they did not have many choices on which location of the home to use for their meetings. To manage their concerns, almost all of our participants wanted to set virtual backgrounds. However, several participants reported that the conferencing tools that they were using did not have this option, or that their devices that they were using did not allow them to set virtual backgrounds. Since then, more conferencing tools started adding these features. However, having this option in the tool still cannot solve the challenge of many of our participants who did not have the hardware that could support setting virtual backgrounds. Going forward, tool developers should make efforts looking into this very common challenge. Designers of these technologies should make such privacy-preserving features more lightweight and accessible by considering the wide range of systems hardware specifications. The second common type of privacy concern among our participants was the lack of co-inhabitant privacy, which refers to not having privacy from other household members. participants were concerned that their meetings were being overheard by those who they were sharing their homes with. To preserve co-inhabitant privacy, future tools can be enabled with a feature to detect and notify the users when other household members are in the hearing range of their remote meetings. The majority of our participants reported that they have no effective power and control over their remote communications. To address their concerns, our participants wanted their employers and educators to set inclusive, transparent, and flexible meeting policies by proactively listening to their privacy concerns, acknowledging the limitations posed by their diverse living arrangements, and making efforts to address their needs. Okay, so now I'm going to talk a bit about the methodology of this research. My goal here was to understand how the context of remote communications impacts participants' security and privacy attitudes and behaviors. Part of this understanding was qualitative, as it came from analyzing participants' open-ended responses by using a structural coding. And part of it was quantitative, as I used participants' close-ended responses to build statistical models that could explain participants' security and privacy attitudes and behaviors based on various factors. In the survey that I designed, I included both the close-ended questions to capture statistically significant effects, as well as open-ended questions for rich qualitative data. Since I had both of these research approaches in the survey, the method that I used was called mixed methods. In the next slide, I will focus on the quantitative analysis and talk about the statistical models that I built. But if you're interested in knowing more about the qualitative analysis, I have some backup slides on the structural coding. To give you an idea of how I quantitatively analyze participants' responses here, I will very briefly talk about one of the regression models that I built. And if you're interested in learning more about this type of statistical modeling, I would be happy to chat after the talk. One of the models that I constructed was to explain participants' level of comfort with conferencing tools. In the survey, I asked participants to specify on a 5-point Likert scale how comfortable they are with the conferencing tools they have been most frequently using during the pandemic. Participants' response to this question was our model's dependent variable. Since the responses were on a Likert scale, the type of our dependent variable was ordinal categorical. The model also included several nominal categorical independent variables, including the type of the context of remote communications with 3 levels of working, socializing, and learning from home, and the type of conferencing tools with 5 levels of Zoom, Google Hangouts, Google Meet, Microsoft Teams, and Skype. A regression model that we can build when the type of dependent variable is ordinal categorical is cumulative link model, which I will explain in a second. But here we have another important consideration, which is that the design of my survey was repeated measures. This means that participants answer same types of questions for different contexts of remote communications. For example, I asked participants about their level of comfort with conferencing tools 3 times, 1 per each context of working, socializing, and learning from home. So when we have a repeated measure design, there might be some dependencies among participants' responses to these repeated questions. In the regression analysis, we count for such within participant data dependencies by including random effects in our models. And a model with a random effect is called a mixed model. So in this study, I built cumulative link mixed models, or CLMMs. In this model, for each of the collected observations, the probability that the participant's response in that observation is at most at level J is modeled at what you see here on the slide. Here, logit is the link function. And what it does is that it maps the response probability to this linear term on the right. Alpha denotes the intercept, or the threshold parameter between response categories J and J plus 1. U denotes the random per participant effect, which is modeled as an IID Gaussian random variable with 0 mean and a variance that is fit by the model. this random variable is shared between the observations belonging to the same participant. And finally, betas are the model coefficients. And for the sake of this talk, betas are the most important parameters of these regression models, as they basically show how powerful the independent variable is in changing the dependent variable. The regression analysis showed that participants had a statistically significant different level of comfort with using conferencing tools in different contexts of remote communications. As a reminder, betas are the model estimated coefficients. So for example, a beta of 0.88 here means that participants were significantly more comfortable with using conferencing tools when learning from home compared to when working from home. And this difference was 0.88 on the log odds scale. So these model coefficients showed that participants were most comfortable with using conferencing tools when socializing from home and least comfortable when working from home. Similarly, participants were most comfortable with the location of their remote meetings when socializing from home and least comfortable when working from home. The qualitative analysis of participants' open-ended responses indicated that the lack of privacy was the main reason contributing to participants' discomfort with their conferencing tools and meeting locations. In this study, I shared the lessons that I've learned from people's privacy decision-making toward remote communications during the pandemic. My research showed that participants had privacy concerns in all three contexts of remote communications, but most significantly when working from home. However, independent from the context, participants felt having no agency over making privacy protective decisions in their remote meetings. I mentioned a few actions that tool developers, employers, and educators can take to empower people to make informed and privacy-aware decisions. Although I conducted this research during the pandemic, its lessons will be applicable and relevant long after the pandemic, as surveys have shown that many people expect to continue to work from home even after the work from home restrictions are lifted. But perhaps the most important takeaway here is that we, as researchers, software developers, or policymakers, don't really have to wait for the next pandemic to design informed and effective security and privacy solutions. Instead, we can continuously learn from people's interactions with technologies to understand what security and privacy needs and concerns they have, and whether the current technologies and policies are enough to address their needs, and if not, taking steps to redesign them. Back to my work desk at home. So far, we've looked into people's security and privacy needs and concerns toward remote communications during the pandemic. Now we move on to another potentially concerning technology in this picture, which is this Amazon Echo, or in general, Internet of Things or IoT technologies that many of us have in our homes and offices. Despite providing convenience and some very useful features, smart devices could expose their users to a wide range of security and privacy risks. A few examples of this risk would be the smart speaker being activated without their users' knowledge and sending out their private recording to others, or smart TVs selling our data on watching behavior to third parties. And a very common example of smart security cameras getting hacked. So people are understandably really concerned about these devices. However, despite their security and privacy concerns, consumers are still increasingly purchasing these devices. So it is fair to say that having security and privacy concerns does not automatically result in consumers making informed purchase decisions. My research objective here was to better understand this gap, the gap between people's concerns and their purchase behavior, and to design security and privacy solutions or interventions to fill this gap. One of our study participants said, "When I bought my smart devices, I don't remember seeing anything under security and privacy, just the name of the device, the price, and some technical info. Many of us have the experience of purchasing a smart device for ourselves or others. Now, I want you to remember the time when you were in the physical store or search online for the smart device to buy. You probably saw the information on the price of the device or its technical specification, for example, its size or internet connectivity. But do you remember seeing any information on the security or privacy practices of the device at the time of purchase? The answer is probably no, because usually this information is nowhere to be found. When purchasing a smart device online or in a store, consumers are not able to make an informed purchase decision, as the information on the security and privacy behavior of the smart devices is not readily available to them. So I use my human-centered security and privacy approach to identify what is needed. And the need that I saw here was to make this information available and usable at the point of sale. For that, I designed and evaluated a usable and informative security and privacy label for smart devices, similar to a nutrition label for food items. This research has also resulted in a significant policy and advocacy impact. A few months ago, following an executive order from the White House, NIST was commissioned to work with other organizations such as Consumer Reports and academic institutions to initiate a pilot program to design security and privacy labels for US consumers of smart devices. In the US, we are the only research group working on consumer-facing IoT labels. So I've been actively engaging with NIST and Consumer Reports to inform their efforts on designing the IoT labels. Although the IoT label is a very new concept in the US, we are currently seeing some IoT labeling efforts in a few other countries, such as Singapore and Finland. Smart devices are being sold globally, so it is important for consumers as well as device manufacturers to have a standard label for these devices. To achieve this, as a member of the World Economic Forum Trustworthy IoT Coalition, I'm also involved in international efforts to develop standards for IoT security and privacy labels. I asked several questions in order to design a usable and informative security and privacy label for smart devices. First, I asked how much consumers of smart devices value having security and privacy information at the point of sale. In the next project, I asked what security and privacy information should be included on an IoT label. And finally, I asked, is the design security and privacy label effective in informing consumers' purchase decision-making? I conducted research to answer each of these questions, which I'm now going to talk about. Starting from the beginning, the first project that I conducted was to capture IoT consumers' attitudes toward having security and privacy labels at the point of sale. For this project, I designed a prototype label that included a few important security, privacy, and general factors, such as the availability of security updates or the types of data the device collects. In a series of semi-structured interviews, I then presented this label to 24 consumers of smart devices. In this study, I did not tell participants that our team designed the label. Instead, I told participants that we are assessing a previously proposed label, so I used passive words. The reason that I did this was to mitigate a type of response bias called demand characteristics. This bias is caused by participants adapting their behaviors and responses to fit their interpretation of researchers' hypotheses and goals. So if they knew that this was our label, then they would have assumed that we expect them to be positive about the label. And therefore, they could have faked their interest in the label to fit this perceived expectation. The qualitative analysis of participants' responses showed that almost all of our consumer participants would like to know about the privacy and security of smart devices before making device purchases. One of our participants said, as opposed to those long policy documents that you usually need to read, I think this is a very efficient way, and I cannot think of a better way than this. So yes, having security and privacy labels readily available at the time of purchase is indeed valuable to consumers of smart devices. So now that we have enough motivation to design the label, the next challenge is what security and privacy information we should include on the label, and how we should design the label so that it's usable and informative for consumers. To answer this, I conducted an extensive literature review and went through more than 70 IoT security and privacy references from academia, governmental organizations, both in the US and international ones, nonprofits such as Consumer Reports, as well as guidelines from companies. Although these references covered several important security and privacy factors, they were all targeted toward experts, and none of the available references talked about what security and privacy information consumers of smart devices should know about. To understand what information needs to be included on a consumer-facing IoT label, I conducted an expert elicitation study. To capture a holistic view, I interviewed and surveyed a diverse and gender-balanced sample of security and privacy experts from industry, academia, government, and NGOs. The recruited experts had to satisfy at least one of the following criteria: being a faculty member in the field of privacy and security, having more than 10 years of research or practice in privacy, security, or policy, being an author of known books in the field of privacy and security, having active involvement in cybersecurity standardization, or leading an IoT security and privacy team in industry. To elicit experts' opinion on the privacy and security factors, I followed a 3-round Delphi process. In the Delphi method, the objective is to reach a consensus among a panel of experts without these experts directly influencing each other's opinions. We reach this consensus among experts after 3 steps. The first stage of the Delphi process is mostly an interview study. I conducted semi-structured interviews with experts and asked them to specify the most important privacy and security and general attributes to include on the label. These interviews resulted in 47 factors that at least 2 experts wanted to see on the label. I then conducted the first follow-up survey, where each expert was assigned to review 1/3 of the attributes to specify their importance, as well as their reasons supporting their decisions. From this stage, I found the most common reasons for including or excluding a factor. In the Delphi method, we have this concept of controlled feedback, which means that the aggregate output of the previous stage will serve as the input to the next stage. We have this feedback loop to allow experts adapt their responses and eventually converge. As part of this feedback process, I presented these aggregate reasons to experts on a second follow-up survey. Here, each expert was randomly assigned to review 1/3 of the attributes, and once again, I asked experts to specify whether they would like to include or exclude a factor now after looking at all the reasons from the previous stage. To analyze the interview responses, as well as the open-ended answers from the surveys, I conducted thematic analysis, which is a recommended qualitative analysis approach when information is high in subjectivity. I followed a 5-step procedure recommended by Brannon Clark to create the codebook, find the themes, and merge them. Let's very briefly go over the steps. In step 1, the primary coder reads the interview transcripts and takes notes. In step 2, the primary coder creates the initial codebook by looking into the notes that were taken in each interview session, as well as the notes from step 1. In the next step, the primary coder combines the smaller codes into broader themes. This step focuses on finding patterns and themes from the long list of codes from step 2. Next, in the project meetings, we discuss the themes that emerge from step 3 and resolve any disagreements. This step helps increase the validity of the themes. In an iterative process, some of the themes are removed from the codebook and some of the themes are merged into more general themes until we reach a consensus on the final themes. And eventually, the finalized themes are moved into the final codebook. Now let's take a look at the labels that I designed based on experts' input. Our experts wanted us to include 47 security, privacy, and general attributes on the label, which is clearly too many to show on a typical product package. Therefore, we decided to design a layered label with 2 layers. The primary layer is the concise format of the label, which could be printed and attached to the package of the smart device. And then there is a QR code and a URL at the bottom that direct consumers to the secondary layer, which has more detailed information and is in an online-only format that can be updated as firmware changes. An important reason to have this online layer is to have a way to accommodate companies updating their security and privacy practices. To assess the label's information comprehension, I conducted semi-structured interviews with 15 consumers of smart devices and presented the label to them. And again, to mitigate the response bias, I did not tell participants that we designed the label, and instead told participants that we are assessing a previously proposed label. I tested the label's information comprehension in both non-comparative and comparative purchase process. I started with a non-comparative process and asked our participants to take a look at the package of the smart device with our label on and define the attributes as well as their values. In the comparative scenario, participants imagined doing comparison shopping for a smart device from 2 different companies. I asked them to compare the labels and specify which company had implemented better security and privacy practices and why. The results showed that almost all of our consumer participants were able to use the primary or the first layer of the label to critically compare the security and privacy properties of smart devices when doing mock comparison shopping. However, as I expected, some of the information on the secondary layer were not understandable to some consumer participants. For example, devices ports and protocols. However, most participants reported that they would still like to see this information on the label to be as informed as possible when purchasing smart devices. One of our participants said, I don't know about TCP and UDPR, but it's interesting to have this here because then I could go to Reddit and ask on there what that means and what the capabilities are. Okay, so far we have learned that consumers would like to have information about the security and privacy of smart devices at the time of purchase. I then talked about designing a layered security and privacy label with 47 factors based on experts' inputs and evaluating its information comprehension based on the feedback from consumers. In addition to being understandable, a consumer security and privacy label is useful and effective when it conveys risk to consumers and informs their purchase behavior, which is what I assessed in the next project. In this project, I explored the impact of 16 security and privacy attribute value pairs on participants' risk perception and willingness to purchase smart devices. For each attribute of the label, I selected 2 values, the most protective and the least protective. For example, for the purpose of data collection, I selected providing main device function as the most protective value and monetization as the least protective value. I hypothesized that most protective values of attributes should significantly decrease the perceived risk and increase willingness to purchase. I expected the opposite for the least protective values. I then launched a large-scale vignette study on Amazon Mechanical Turk. The survey that I designed had a mixed design, which means that it included both the between subjects and the within subjects factors. The survey design had 6 experimental conditions based on 2 between subject factors of device type and the device recipient. I tested 2 types of smart devices with varying risk profiles, a smart speaker and a smart light bulb. I also considered 3 levels for the device recipient, purchasing a device for yourself, gifting it to a family member, or gifting it to a friend. The within subjects factor was a privacy or security attribute value. Using these factors, I then generated several hypothetical purchase vignettes, each asking participants to imagine purchasing a device type for a device recipient with a specific security or privacy practice. For example, the scenario said, the purpose of data collection is monetization. Each participant was presented with 3 such vignettes. At the end of each scenario, in 2 questions, I asked participants to specify on a Likert scale how each attribute value would change their risk perception, and in the second question, their willingness to purchase and why. I then constructed 2 cumulative link mix models to explain participants' risk perception and their willingness to purchase. We previously talked about CLMMs, so I will skip the details here, but perhaps the only important information that I would like to remember from these regression models is the model coefficient, or beta. As a reminder, generally speaking, the coefficient signals the magnitude of change caused by the independent variable in the model. The regression analysis indicated that almost all of these security and privacy attribute value pairs effectively conveyed risk to consumers and significantly influenced their desire to purchase smart devices. Using the model coefficients, I then ranked the effectiveness of these attribute values in terms of changing participants' risk perception and their willingness to purchase. Starting with the risk perception, the top 3 factors that significantly increased the perceived risk were sharing data with third parties, having no control over access, and selling data to third parties. On the other end of the spectrum, the top 3 factors that decreased the risk perception were having multi-factor authentication, no data sharing, and having no cloud retention. In terms of willingness to purchase, the regression results showed very similar trends. The top 3 factors to increase participants' desire to purchase a smart device were having no device retention, having no cloud retention, and no data sharing. And the top 3 to decrease the willingness to purchase were sharing data with third parties, having no control over access, and selling data to third parties. My goal for the label is to be used by policymakers when assessing the security and privacy practices of smart devices, as well as the device manufacturers and consumers. To provide the information that is needed by all these stakeholders, I prepared a specification document where, among other information, I provided the complete taxonomy of the label. For real-world impact, I would like to have our labels adopted. And to ease the process of generating the labels, we developed an interactive tool that allows users to complete a form for different sections of the label and then see the label being generated in real time. In the most current version of the tool, users can download the label in the formats of JSON, XML, and HTML. Users can also work on the label offline and then upload the saved JSON file to resume working on it. Several IoT device manufacturers contacted us to use this tool to tailor the security and privacy label for their IoT products. For this, we are now working on making this tool open source so that device manufacturers can voluntarily adopt the label. So we just learned that the label is effective in conveying risk to consumers and informing their purchase behavior. In this presentation, I primarily focus on 2 consumer technologies that I have in my work from home setting: remote communication technologies and IoT technologies. But these were just 2 technologies in one bedroom. Each of our homes has several of these technologies, and we now have smart technologies in our cities. There's not much time left in this presentation to go into the details, but I have another ongoing project where I'm studying the security and privacy needs and concerns of financially marginalized neighborhoods towards smart city technologies, and specifying how the citywide IoT technologies and the policies of city stakeholders should be informed by people's diverse needs and concerns. Okay, so far in my talk, I've covered most of my current and past projects. I particularly focus on smart home devices, smart cities, and remote communication technologies. Now, I want to spend a few minutes talking about 2 research directions that I'm passionate about and discussing the vision that I have for my future research. My past research was primarily focused on the security and privacy needs and concerns of non-expert users and consumers of technologies. But this is a very broad category that could include several subpopulations with diverse properties and diverse needs. For example, 2 populations that I very recently started looking into are the victim survivors of intimate partner violence and the blind or low vision individuals. Starting with the IPV victim survivors, I'm designing a study to understand the security and privacy needs and concerns of people who have experienced IoT abuse. One example of this type of abuse is when the abusive partner is using the security cameras to spy on the victim survivor. Using this obtained knowledge of needs and concerns, I will then design security and privacy solutions to inform the victim survivors of the potential IoT abuse and educate them on how to protect themselves against the risks. In addition, I want my research to provide a guideline for IoT device manufacturers as well as policymakers to more effectively protect victim survivors by designing IPV-aware technologies and regulations. The second community is the blind or low vision individuals. The BLV population use visual assistive technologies or VATs to get a better sense of the images or videos they take from their surroundings. But sometimes there could be some sensitive information from themselves or a bystander in these visual contents, which could result in some privacy risks if being shared with visual assistive technologies. So we are now conducting a series of in-depth interviews with BLV individuals to explore their security and privacy needs and concerns when using visual assistive technologies. So far, our research has surfaced a strong desire for the BLV individuals to have information on how these technologies handle their sensitive data and what controls they are being provided with. To empower their decision-making, I'm going to design security and privacy transparency tools that inform users about the practices of these technologies. Last but not least, I want to work with VAT developers and use my research findings to inform their security and privacy efforts. If you're interested in knowing more about any of these research directions, I would be happy to chat in our one-on-one meetings. In my 3 ongoing research directions on smart cities for marginalized populations, IoT in the context of domestic violence, and the visual assistive technologies, I started to take usable security closer to the communities that have been harmed the most by technologies and policies. In a more traditional sense, usable security and privacy is focused on understanding how the current design of technologies and policies need to be changed to become more usable. In this sense, we are mostly designing for people. However, going forward, I want my research to take a different approach and instead design with people. Through this perspective, I want my research to uncover and tackle the root causes of people's security and privacy needs and concerns by centering the marginalized voices of those who have been impacted the most by technologies and policies. The methodology of this type of user research is incredibly important, as our methods should be designed to amplify all voices, not only the loudest. Also, the methods should not expose the participants to further harms. For example, to understand the needs and concerns of victim survivors of intimate partner violence, we cannot simply invite them to come to our lab for an interview study, as this could first re-traumatize them, and second, pose a huge danger on their lives if this becomes known to their abusive partners. After designing equitable methods to surface the needs and concerns, I will then use the obtained knowledge to design the needed security and privacy solutions. In addition, for this research to have societal impact, I will work with diverse stakeholders, including policymakers, to help them shape policies that address the needs of diverse populations. As a final note, I want my human-centered research to have a continuous engagement with communities. And as one of the core principles of design justice, I will close this loop by sharing the knowledge that I obtained, as well as the tools and policies that my research has contributed to with the affected communities. I would like to end by thanking the amazing people that I've worked with. Throughout my PhD and postdoc, I've mentored several brilliant bachelor's, master's, and PhD students, and worked with wonderful faculty members, postdocs, and industry collaborators. And with that, I would like to thank all of you for joining my talk, and I would be happy to answer your questions now.
Great talk, Pardis. So I'm the only one, but all others also virtually. Okay, so now so Pardis will take the few questions. So yeah. Yeah, Eric.
Sure. Thanks for the talk. This is really interesting. I'm curious. You found this nice result that users are sort of seemingly more likely to buy something by a device if it preserves their privacy in some meaningful way. Were you able to quantify that in a way that you could go to, say, a company and say, look, product X is worth $100, but people would pay $110 for a privacy-preserving version, or you could scoop this competitor for this kind of thing, right? Incentivizing privacy from the economic side of this.
Yes, of course. Thank you so much for asking the question. And that's actually a great question. So there's another ongoing project that I currently have with my mentors at Carnegie Mellon, which is basically to understand how much of a premium consumers are willing to pay to have security and privacy information available at the time of purchase. So hopefully the results of this project will be published soon. But basically in this work, we used a incentive compatible method from economics and try to simulate the real purchase behavior to basically understand how much consumers value security and privacy. And we basically looked into several improvements in terms of security and privacy. For example, going from no security update to having automatic or manual update. Or if the device manufacturer can guarantee that they are not selling users' data to third parties. And we found that consumers actually value security and privacy a lot. There are several of these factors that they're willing to pay a significant dollar amount. There's definitely some differences between how much they're willing to pay. For example, the update that I mentioned, going from no security update to, let's say, automatic, it is valuable. But if you can guarantee that you're not selling the data, it is significantly more valuable in terms of the dollar amount that they're willing to pay. And there are also some very interesting kind of findings in that sense. For example, we as security researchers think that security updates are very valuable should be valuable to consumers because it's more convenient. But actually consumers preferred, or they were willing to pay more for manual update because of the autonomy and agency of installing the updates. And they were also afraid that the update is going to break their devices. So there were some interesting usability, the tension between usability, convenience, and security and privacy that we surfaced in this study. But yes, we basically conducted that study and we reported the findings. And currently I'm a consultant at Consumer Reports. And as part of my engagement with the CR is to have device manufacturers pilot the security and privacy label on their devices so that we can measure the efficacy of the label in actual purchase behavior. That is another component of this project that I'm basically going to do next.
Okay, so next, Leisha.
Hi, Pardis. Thank you so much for your talk. That was just terrific. I love what you're doing. I love the methods you're bringing to all of this, the mixed methods. It's terrific. I just wanted to ask you a question on just some of the last future projects you brought up, particularly on the matter of helping people who are victims of domestic violence in terms of expressing their privacy concerns, which are I learned from Sunny Consalvo. I don't know if you're working with her.
No, I'm not.
Because of the Intel connection.
Yes.
Huh?
Yeah, she's at Google, right? I know her, but I haven't worked with her. Yes.
Yeah. So she's found it even hard to publish on some of the stuff because of the privacy restrictions are just at a level that are almost insurmountable. But anyway, I've learned from her how difficult all this is. Are you able to just express a little bit more what a research design like that might be? And I don't want to put you on. It's not too much pressure. I realize it's going to be so contextualized depending on who you're speaking to and about what. But bringing them into the lab is, one concern, but actually not bringing them into a physical situation and doing things over digital media is even a worse concern. So I don't know how that would be done. And I would just love to know your thoughts on it because of just how difficult it is.
Yes, of course. Thank you so much for mentioning all these important considerations. But yes, it is very difficult to conduct this kind of like type of user research, and specifically related to IoT in domestic violence. The way that we are recruiting participants is through the shelters, actually. So we basically contacted several shelters, some in Bay Area, in San Francisco, some of them in even, this is kind of like a joint project. So we have another collaborator in Wisconsin-Madison, and there they have a tech clinic. And basically in that tech clinic, the clients would come and ask about their concern related to technology in general, like their smartphones, their computers. And some of them have concerns related to smart devices. So we designed this interview transcript, and our collaborators at Wisconsin-Madison would then sit with the client and ask these questions. So we are not doing this over, for example, Zoom. They're doing this like in that tech clinic. There's another tech clinic in Cornell Tech, actually. And they're also involved in this type of research, but that is also more related to traditional technologies, not specifically smart devices, but they have some clients that are concerned with that. So we are basically conducting the interviews there as well. But it's basically, I think it is mostly true, or it's all of them is through the allies of these population of the shelters, basically. We're not directly interacting with them. And also in all of the interviews, especially through the shelters, in all of the interviews that we have with the victim survivors, there's at least one volunteer present at these interviews so that they can basically help with all the situations that we cannot actually help the clients with.
Great, thank you so much. And I imagine those tech clinics, the technicians are actually finding the snooping software that then gives rise to perhaps more questions that the victim survivor didn't know they had about what was happening to them too, right? So that's a...
Yes. So basically, they're really concerned about the types of apps they have on their phone. For example, they're saying that is any of them are spyware? Can I like uninstall them? If I do that, what if the abuser would know that I did this? Is that going to like even make the situation worse? But in the specific related to smart devices, the types of concerns they have is that some clients don't really know about the types of devices they have at home. They're saying that I can see some of the cameras, but I'm sure that you have more of this. So they don't, for example, know about the types of devices, the types of practices of these devices. So I think we see all the range of concerns among the clients.
Thank you so much.
Of course.
Okay, so next is Jessica.
Hi, thank you so much. This was a really interesting presentation on so many levels, and thank you for doing work with domestic violence victims and bringing that into the equation. I have several questions, and one has to do with, you know, how the EU has required that websites be transparent about their cookies.
Mm-hmm. Yep.
You can opt in and out of various cookies. I don't know if that's something that happens in the US much, and what do you think about that approach and taking it one level further? And then also the question about, you know, people are willing to pay more. They say that, but do you see evidence that they do actually pay more? Because there's a difference between I'm willing and then.
Yes, of course. So related to the first part of your question about the cookies, and so I think one reason that people like to have such notices is basically it kind of also gives them some control over their data. So that's why kind of like people like to have such notices, and so kind of like if they can opt out from that. But I'm not exactly doing research in that specific topic, but I've read papers that are talking about the usability challenges of these notices, and also the time that these warnings are being shown when you visit a website. So there are like different, I think, concerns related to that, and people have different preferences on this. So I know that there are researchers who are trying to improve how such warnings should be presented to people. So that's about just the first part of your question. The second part, it also kind of goes back to the study that I mentioned about the economic value or the monetary value of security and privacy. So that in that specific study that I conducted, although the method was still a survey, but we tried to simulate actual behavior. And we used some deception methods in that. So basically participants or consumers thought that they have to put their credit card number up until the last stage of the study. So money was involved in that specific study. So basically the risk was there as well. That was kind of like the closest study that we can do when we cannot really have the label. But we think that the result of this study could reflect actual behavior. But as I said, this is something that I'm going to do with consumer reports. We are really going to test the importance of the label and whether they are, for example, willing to pay for security and privacy. But at least on paper or in that study, it shows that they are willing to pay a significant dollar amount.
Oh, and then I do have a question about, are tech labs prevalent throughout the country for domestic violence survivors? Or
Sure. So the only two that I know are in Cornell Tech and in Wisconsin-Madison. And the Cornell Tech, I think, was designed a few years back. The Wisconsin one is very new. It's like a few months ago that they actually created this Cornell Tech. And the person who designed it was the PhD student of someone at Cornell Tech who designed the tech lab there. So I think they're not that prevalent in the US. They're just only in I think they're just in Ithaca and in Wisconsin.
Thank you.
Of course.
And Saleh no Mubarak.
So we just basically said Happy New Year.
One question in the chat that have any of the consumers had their machines attacked? I mean, yeah. So I think definitely that you know more about that too.
Have any of the consumers had their machines attacked? Interesting. So the type of concerns that they had was not about their actual experience. They were concerned about, their concerns were mostly coming from the articles that they read on the news about, for example, especially smart speakers, actually. So they did not have an experience with their own devices getting attacked, or at least they were not able to report it. But it was mostly about the news media and the types of concerns that were being reflected there.
Mm-hmm. Okay, so I think, yeah, so thanks to the speaker again. And yeah, and then, so Pardis and I will stay here longer. And if you have any other questions, just stay here. And then, yeah, thanks a lot.
Thank you so much. Yeah, thank you so much for the great questions.